Hello, people. Okay, so we are at section 9.1. This is day one of a 2-day lesson for section 9.1, and we are going over sequences. Okay, so first off, with sequences, we have an infinite and we have a finite. Okay, so for an infinite, okay, an infinite is, or an infinite sequence is a function whose domain is a set of positive integers. For a finite, okay, is when the domain whose domain consists of first n positive integers. First positive integers only. Okay. Now, sequences all there's usually a pattern, or there is a pattern involved when you're doing it. Like if you've got 1, 2, 3, 4, there's definitely a pattern going on there. If you've got 1, 3, 5, 7, obviously the pattern is they're increasing by odd numbers, or they're increasing by 2. Okay, so that's what we're going to go through in these things for sequences. Okay, so we'll start with the first example. Okay. Okay. Write in the first 4 terms of the sequence given by a sub n equals n minus 2. What we're doing here is this subscript right here, n, whatever we plug in, is going to fill in for right there. Okay. So here in this case, we are going to start with a sub 1, a sub 2, a sub 3, a sub 4. Okay, so these are the first 4 terms of this sequence. Okay, so here, a sub 1, again, we're just going to plug in the n, the 1, in for n. So we get 3 is 1, minus 2, so a sub 1 is equal to 1. This is our first term. Okay, so 3 is 2, minus 2 That's going to be equal 4. This is our second term. A sub 3, 3 minus 2, that is 7, and that is our third term. And of course a sub 4, oops, and that is our fourth term. Okay. Again, if you notice a pattern here anywhere, the little pattern in the sequence is telling us that it is actually increasing by 3. If you're trying to figure out a sequence, again, each one is increasing by 3. All right, then we get a series where we will have alternating signs. Okay, first one, these were all positive. These right here, okay, you'll see in the end that the signs start to change. So again, we'll start off with a sub 1, a sub 2, a sub 3, and a sub 4. So again, we're just plugging them in. We'll have -1 here. Okay. To the 1 times 1. And we get -1, 2 plus 1, and this gives us -1/3, and that is our first term. Okay, so forth. We've got -1 squared, 2 times 2 plus 1, that equals 1 over 4 plus 1, which then equals positive, sorry, 1/5. So here's where it goes from negative to positive. That's our alternating. So this is our second term. Okay. A sub 3, start running out of room. -1 to the 3rd, all over 2 times 3 plus 1 plus -1. 6 plus 1 equals -1/7. Okay, again, now that is the third term. Okay, we'll go with the fourth term. -1 to the 4th, 2 times 4 plus 1, that is equal to 1, positive 1, plus 1 equals 1/9, and that is the fourth term. Okay. Okay. So that's how we go with alternating signs. Okay. Next we have is a recursive sequence. Okay, a recursive is a sequence which you need to be given one or more of the first few terms. Okay. So recursive. Okay. It's requiring one or more of the first few terms. Okay. So right here it says we want to write out the first 5 terms of a sub 1 equals 3, a sub k equals 2a, k minus 1 plus 1. But our k has to be greater than or equal to 2. Okay. So again, we'll start out with a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Okay. Our a sub 1 tells us that it is 3. A sub 2 is going to be 2. A 2 minus 1 plus 1. Okay. So this is 2a, 2 minus 1 equals 1 plus 1. Okay. So our a1 is this right here. So we'll get 2 times 3 plus 1. So that equals 7. Okay. So a sub 3 is 2a, okay, 3 minus 1 plus 1 equals 2, 2a2 plus 1. Okay. A2 is 7. So that is 2. Let me fix this A. It looks like sub A. 2 times 7 plus 1. And that is equal to 15. Okay. Keep going. 2a 4 sub 4 minus 1 plus 1 equals 2a 3 plus 1 equals 2 times 15 plus 1, which gives us 31. Okay, and the last one, a sub 5, 2a 5 minus 1 plus 1 equals 2a sub 4 plus 1, which equals 2 times 31 plus 1 equals 63. Okay? Alright, let's move into factorial notations. Okay? We'll do the definition of factorial if n is a positive integer then n factorial is defined as n factorial equals 1 times 2 times 3 times 4 keeps going, n minus 1 times n. Okay. All right, let's go with this problem here. Okay, we want to write out the first 5 terms as given in the sequence by a sub n. Okay, we'll do this just algebraically. Okay, the one thing about factorials, though, we need to put this in here. 0 factorials is defined by sorry, 0 factorial, which equals 1. Okay, so when we are doing sequences involving factorials, our a sub n, the first term, is always going to be a sub 0. Okay, this has to do with factorials. So here, we're just going to plug in zeros in there. 2 to the 0 all over. To the 0 all over 0 factorial. Anything to the 0 power is just going to give you 1, and 0 factorial equals 1. So our first term, of course, is actually, and this is actually the 0 term. Okay, that is the 0 term. A sub 1, we'll go 2 to the 1, 1 factorial, 2 over 1 equals 2. This is our first term. A sub 2, 2 to the 2, 2 factorial equals 4 over 2, which equals 2. Second term. A sub 3. Okay. 2 factorial, 2 to the 3, sorry, all over 3 factorial equals 2 times 2 times 2 is 8. 3 times 2 times 1, 6, which equals 4/3. That is the third term. Okay. And a fourth. That is 2 to the fourth. 4 factorial, which equals 16 over 24. Okay, and that is the fourth term. Total, we have 5 terms. 0 is counted as one of the terms. So there's how we do our 5 in there. All right, so the last part for today is simplifying the factorial expressions. We'll start with a. Okay. Okay. So 8, if we were to do that, spread that out as factorial, that'd be 8 times 7 times 6 times 5 times 3 times 2 times 1. Okay. And then we have 2 factorial times that. So what we're saying is we have 2 times 1 times 6 times, we forgot a 4, times 5 times 4 times 3 times 2 times 1, and we can just cancel these out here, and we're left with 8 times 7, which is 56, over 2, which is 28. Okay, and that's simplifying that. Okay. B, we have n factorial. Okay, this one's a little bit more trickier. Okay, so up at the top, I want to make sure that we stated that n factorial, this is it right here. Fix this. N factorial is equal to 1 times 2 times 3 times 4 dot 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 n minus 1 times n. Okay, so we've got here is n factorial over n minus 1 factorial. Okay, so the top part is going to be 1 times 2 times 3 times 4 dot 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 n minus 1 times n. Okay, that's just that by the definition. Now our bottom part of n minus 1 factorial is just this right here. Okay, 1 times 2 times 3 times 4 dot 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 n minus 1 with no n on the end. Okay, so these cross out, and we are just left with n. Okay, all right, so Monday morning we'll be here to answer questions on how we do this, if you have any others. Okay, and we will, because I know I'm running out of minutes here, we will talk about this with regards to that. I'll probably make a separate video on that as well. That way we get over on Monday. But I'm starting to run low on the amount of minutes I could do. All right. Talk to you Monday. Take care. God bless. Bye-bye.